Welcome back, everybody. Another AMA. Tonight is going to be a very exciting time. Ruben, I've been just looking through the chat here, and it's always amazing to see how many people are connecting from all over the world. We have an amazing group again, and we have an amazing itinerary for you guys tonight. Jason has lots planned, so make sure you buckle your seatbelt, strap in, because there's a lot going to be coming at you. Ruben, why don't you give them just a little bit of an idea what they can expect tonight?
Absolutely, Misha. Incredible again to see people literally from all the 5 continents. There's a full program, and Jason's just told us that it's going to be a little bit longer, so there's a lot to share. And as usual, he's going to present for about 50 minutes or so. And after that, we're going to have the usual AMA, the good and fun part, where you can ask questions directly to Jason through the chat and also hear other people's questions. That's really the good fun part. Anything is possible. You can ask anything. And we're going to take that for another hour. So we're going to be closing exactly in 2 hours. Great to have you all. Thank you again for joining. This is the year 2023 where everything is coming together. Another AMA. So Jason, please go ahead, and thank you to be taking the time to be with us again to literally update the world on the build of the HS50. Go ahead, Jason.
Thanks a lot, Ruben. Thanks a lot, Misha. Welcome, ladies and gentlemen, back to DC1 for a crammed update tonight. The update will take the usual format. We'll start talking about the airframe developments that have been going on over the last month or so. We'll then get in and talk about engine and drivetrain. We'll talk about the DigiCockpit and all of the software and hardware developments that are going on there. And then we'll wrap up with some exciting news. So let's get started with the airframes. So as you'll remember, over the course of the last year, we have developed a composites facility from scratch, developed patterns, developed molds, built the staff and the workforce, and then built no fewer than the first 5 HX50 airframes. Let's, before we get into the details of what we've been doing recently, have a quick recap about what we've done over the course of the last 6 months or so. So Airframe 1 was very much about making sure we could use Infusion to be able to develop cost-effective composite aerostructures for HX50. That's key to unzipping the power of composites at a price point that GA can afford. So this first fuselage was very much about, can we stick the dry carbon fiber into the molds? Can we hold it in place? And then can we distribute the resin around the mold effectively? We did that, and then with the second airframe, we moved on to try and improve the detail in the molding. So trying to resolve things like edge details, and starting to look at how we template and how we position the foams and the B surfaces into the mold. The third airframe then allowed us to perfect that process on the outer skin. So by the time we'd got to the third one, we're resolving the edge details and all the intricacies of the carbon structure to production standards. And then with Airframe 4, that was where we were due to bring all of the elements together. So let's go back and have a look at what we did with Airframe 4. So Airframe 4 really brought absolutely everything together, everything that you needed to have a high quality, low cost aerostructure. So all the edge details were in, all the foam cores were in, all the metallic inserts were in, the B surfaces were in there that give the structure its strength and its stiffness, and then it was about perfecting the infusion control. Now this airframe was actually in the mold on the day of the last AMA, and as you'll remember me reporting, we had a vacuum hose come off and the thing slumped in the mold and was a process failure really. But that taught us a lot about infusion, it taught us a lot about process control, and when we actually got the thing out of the mold and had a look at it, what it taught us was these structures are incredibly strong. So we were able to refine the process controls, we were able to refine the way that we do the infusions and move on to the next airframe. But above all else, what that proved was we can make stiff, strong and cost-effective aerostructures using the processes that we've developed. We then moved on to airframe number 5. And this was really just a case of refining it, trying to get to the point where we're making a perfect aerostructure that's worthy of a structural test. So in this fuselage, we'd got a fully featured moulding. The A and B surfaces were both in there. Off the back of the latest FEA analysis that we've been doing on the structural optimization and the findings from the perception of the fourth fuselage, we managed to back the laminates off a little bit and reduce the weight dramatically of the fifth one. All the edge details, the cores and the metallics were in there, and we really refined the production processes to deliver what is a near perfect moulding. And what we found when we got this out of the tool was this airframe is incredibly light. The whole monolage with everything in there, the foam cores, the metallics, everything you need to attach all the mechanical components and whatnot is just 50 kilos. Now, obviously it will put on more weight. We've got to bond in some internal panels to make the floors and the fuel tank closures. We've got to put doors and windows on it, but we are on track for weight, we are on track for performance, and we're now able to produce these mouldings very, very cost effectively and very, 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 very quickly, even without yet implementing the automation that will be used in production. So we took everything that we'd learned from all 4 of these airframes, and we brought that together from pattern making, mould making, all the way through to part making, to deliver what was intended to be a production grade suite of patterns, tools and molds using the tail boom or the aft half of the fuselage as a dry run for that. We basically embedded everything that we'd learned in terms of vacuum integrity, in terms of surface quality. We released all of the refinements on the gantry mill to get better performance out of the mill, better quality machining right from the get-go. And then we also took it as an opportunity to avoid designing in some of the challenging features that can make the production process more difficult. So again, reaping the benefits of that vertical integration where the people that design the stuff are in the same company as the people that make and handle the stuff. All of these things were rolled out, and over the course of the last month or so, we've actually built the very first HX50 prototype tail section. So we'll tell you a little bit more about that later, but fundamentally, over the course of the last month, we've essentially got to the point where we're building high quality monolages, and now we've built the very first HX50 tail boom as well. So one of the other areas that we've been working on over the course of the last 12 months really is the way we deliver the lighting on HX50. So we've set out to deliver the first truly private helicopter. And while we're speaking primarily to people that are already in the helicopter market at the moment, as our business grows and our market grows, it's important that we re-expand general aviation to what it used to be in the 60s and 70s. And to that, we have to have broader appeal. So one of the areas that we've been keen to excel in is making sure that we exceed all of our customers' expectations in terms of the presentation of the aircraft. And lighting is one of the major areas that we need to excel in to deliver this. So we're delivering aerospace standard lights that are fully compliant with the certification regulations, but with the theatre of premium or automotive lighting clusters. So what we're looking at here is the nose cluster, which sits in the very front of the airframe behind the windshield. At the top of that cluster, it presents a 3D form of the Hill badge, and then below that you've got your dual focus long range and short range landing lights, which work in sympathy with the wingtip lights that provide a broader, steeper coverage. And these lighting clusters are designed and manufactured and optically optimized by us here at Hill to make sure that we can deliver automotive grade lighting presentation and the jewelry that bedecks the body of the aircraft at a price point that works for general aviation. So within the nose light cluster, you've got the badge, the landing lights, but also the forward portion of the strobe light. So there'll be much more on this coming over the course of the next couple of months as we prototype this and do all of the optical testing on it. But I thought you'd be pleased to see how this is evolving. Similarly, the wingtip lights originally were going to house both the green and red navigation beacons, and also a portion of the landing light. With the addition of skids to the airframe at customers' request, it now means that we can't fully comply with the lighting in those wingtips. So we're now using the wingtip lights to extend the landing light coverage, and then just present that in a way that dresses the airframe properly. Henry's been extremely busy over the course of the last couple of months, refining this, fitting it in with the structural design of the aircraft, and working with Hayden, our optical specialist, to make sure that all of these lights are fully compliant with the regulations. What you can see on the screen there is where Henry's up to with the tail light at the moment, that provides both the aft navigation light and also the aft and lateral portions of the strobe light cluster. So again, aerospace performance, but automotive levels of design sophistication. One of the other areas that we're very keen to do is make sure that the aircraft is presented in essentially to the same level that a premium automotive car would be. Right from the early days, we've been discussing the idea of using a pinstripe of colour that runs along the top of the chrome strip that sort of punctuates the waistline of the aircraft, to give you a sort of handshake when you first open the helicopter with your key fob. The lights will draw down to the nose. And what the guys have been doing over the course of the last month or so is implementing the lighting clusters, the diffusion technology, and working out how to present that in a way that's subtle, classy, and compliant with all of the regulations. So at the moment, we're just exploring a number of optical solutions for delivering everything that we need to before we put the high quality optics and finishes over the top of that. But if we just go over and have a look at fuselage 3 over here, what you can see here is we've got one of the diffusive elements in the fuselage for the green navigation light. Now, the idea of this is this light will be embedded in the door and embedded in the chin window here. And when you open the helicopter, it'll draw down to the front as you flick the navigation lights on. It sits behind polarizing filters, so you don't get any stray light where you're not meant to. And it works in conjunction with a primary navigation light that sits just down here to cover the range of the coverage that you can't quite get to with the stripe. But the idea of this is it just gives you a completely distinctive signature when you're flying at night in the sky, and just brings the aircraft to life that bit more than a conventional bulb in a box would do. So we're really pleased with how that's coming on. Again, don't read too much into the presentation of that at the moment. That is purely an engineering trial, and the level of sophistication will come to follow once we finish the nose and the tail light. So very pleased with how that's coming along. So one of the other areas that we've been working on intensely with the fuselage and the aircraft development is the glazing. So it's absolutely crucial, given the high cruise speed of HX50, that we have impact resilient windscreens. And for that reason, and again to control the costs, we've been working over the course of the last 12 months or so to develop the forming and the trimming processes to be able to produce both polycarbonate and acrylic windscreen panels that have the necessary UV, infrared, tint and hard coatings on them, as well as the blackout or the fret around the periphery that allows us to create a high integrity bonded joint back to the airframe. What we've been doing over the course of the last month or so is primarily focusing on the tooling, because in order to create the kind of optical quality that you need, the blemish-free, distortion-free view through the transparent regions, we have to make sure that the tooling that we use is totally seamless. The original prototype tools that we made for the windows were made in a low-cost way, just to prove that we could physically form the shapes that we needed to using the vacuum forming process. We validated that, and now we've got to take the tooling to the next level to make flyable sort of aircraft parts without any optical distortion. We're proving this process by cutting back and pasting some of our existing tools, and then once we've done that, we'll extend that to either carbon or highly polished aluminium tooling to get the optical quality. What you can see the guys doing here is proving out the trials of the polycarbonate and making sure that we can physically trim and handle the polycarbonate in the same way as the acrylic. And then the other thing that we've been developing is the physical fret or blackout layer, which I can show you down here on the floor at the moment. So what you see in front of you here is one of the recent moldings of a forward windshield panel. As you can see, we've got a high quality optical molding here, but we also have to create this blackout region that sits within the area that we trim the window, and this allows us to essentially hide the bonded connection that goes back to the airframe. The other little details that we're building into this is the dot fade that we use to give it that air of sophistication and to present it in the same way as you'd expect on an automotive vehicle, so you don't have that harsh black line where the airframe transitions from solid opaque material into the transparency. And all of that has been carried over. We've still got a bit of work to do in terms of finding the right combination of the frit material and adhesive so that we're not limited by the adhesive strength of the blackout ink or the coating that we use here. At the moment, that's not quite strong enough, and so we need to do a little bit more development on that. But aside from that, in terms of the process, in terms of the delivery of the printed blackout and the tooling solution for this, we're flying along with this at the moment. So really pleased with how that's coming along. And as of this month, we are able to make crash-worthy polycarbonate windows for the front of the aircraft. A few bits of tidying up left to do to make sure that this is of a presentable quality, but it's looking really good. Okay, one of the other areas that's absolutely fundamental to HX50 is the customer experience. The aircraft has to be exquisite in every detail for every single one of our customers, whether you're the tallest and broadest or whether you're the smallest and tiniest. So one of the things that we've been doing over the course of the last week or so is we've taken Fuselage 4 and we've built into it a range of sort of rapid prototyped interior components, the structure out of our crash-worthy seats, the flight controls, and put representations of our digital cockpit in there so that we can validate the fact that all of the human factors elements that we've designed work as we expected. So we want to make sure everybody's comfortable. We want to make sure the view's right. We want to make sure that collective that some people find novel works as we expect it to with the armrest. We want to make sure that the cyclic range works as we want it to, and we want to make sure that the access is right to the aircraft also. And so what we've done is we've turned Fuselage 4 into a human factors mock-up, and what I can show you now is some of the key findings from doing that piece of work. So again, don't be put off by the appearance of this. This is meant to be quick and dirty, just to validate as quickly and effectively as we can that all of the features that we need to work properly in here work properly. So if you just come around here a second, Josh, what you can see here is we've presented a lot of the airframes previously about 100 millimeters higher off the floor than they sit in reality. This airframe has had its base cut down and sits at the actual height that HX50 will sit at on both wheels and skids. So what you can see, I'm 6 foot when I stand up straight, and so the seat is at a convenient height for me and for people that would be a little bit shorter than me. And one of the benefits of our cyclic, of course, is that you can lift it up out of the way to slide in underneath. So access into the helicopter is comfortable and fairly straightforward. And the first thing that you realize when you get in is that everything that we wanted to deliver in terms of the sort of cosseting flying experience is delivered in spades with this. The digital cockpit looks absolutely fantastic. My personal concern that this was going to block too much of the view was unfounded. I can see easily less than half a meter in front of the nose of the helicopter, and that's without using any of the transparent background technology we've got on the DigiCockpit. The start panel falls immediately to hand, so starting the helicopter is as simple as power on, avionics on, start, and the reverse to shut it down. The collective that some people found a little bit contentious at first falls immediately to hand and sits really comfortably in the normal flight position. As you can see, my arm comfortably clears the armrest, and it's quite easy to rest my elbow on the armrest while the collective's in the flight position. Just as intended, Josh, if you want to come around here, the Digi cockpit and the IPI sits right next to where my hand rests naturally. So my hand rests naturally where the puck falls, and then the IPI for our audio panel, our comm radio selections, or any of the other key functions are immediately at hand as well. So the general presentation of the cockpit, the aspect out of the fuselage, the room and space that I'm afforded is everything that we wanted it to be. And of course, the full-size iPad front and center in the cockpit works really well as well. So we've been exploring the level of adjustment that we wanted to include in the aircraft. The seat range that we've included here allows for someone that's up to about 6'6" and slides forward to someone that's well below the 5th centile. So we've got adequate room for the largest and the smallest. The cyclic range is comfortable for everybody in that size range as well. The only thing I think we're going to end up altering before we go flying is the range of travel on the pedals. I think that's a little bit too little at the moment, and I also think we need a little bit more adjustment on the pedals. But overall, the overall experience in here has been really fantastic. I'm delighted with how this has come out. So very pleased with how all of that's come together. There are a couple of areas where some of the structural developments in the aircraft have impeded a little bit that we're going to refine slightly before we build the next fuselage, but nothing major on that front. You may also note we've put a couple of dirty grey handles here. These were just for engineering purposes. We've been trying to work out where the most convenient place to help shorter people swing in and swing out of the aircraft would be. This obviously won't be a rigid handle in practice, it'll be a leather strap, but we found that location is really convenient to allow you to swing in and out of the aircraft, irrespective of your size. The other thing that we'd just point out as well is that we've maintained the stadium seating, so you have a flat floor across the aircraft, but we've still got a level of stadium seating in the aircraft that ensures that everybody that sits in HX50 has an amazing view. So again, we've popped a little handle up here just to make it easier to get into the back. And what you find from here is, again, if you follow the waistline down here, the armrests are in exactly the right position. The 500 millimeter wide seats are perfectly adequate for 5 fully grown people. And then the beauty of having the slight stagger between the front and the rear seats, of course, is everybody gets a great view. I can see straight over the pilot's shoulder, I can see straight out of the pilot's side window, and of course I've got a great view here. Lots of shoulder room, lots of headroom, and easy access to the roof console for the air conditioning and other bits and pieces that we've got in there. So overall, really pleased with how this has come together. There's a couple of details that you won't necessarily make out until we put the bonded in floor panels in there, but these open flanges that you see on the structures, the floor actually butts directly up to those, and we've got some metallic finishes that go over there. So all of the open flanges are either protected by ruggedized seals or by finishers, so you're not going to damage the core structure of the aircraft. So overall, the human factors exercise has been really helpful, very quick and dirty, but it's just validated that everything that we wanted HX50 to be, it really is. You're going to love it. Okay, let's talk about the GT50 engine for a second. A lot of the effort in the company has gone into the GT50 engine development. In particular, the march towards freezing the final elements of the engine, getting the engine components built, and then getting a phased build of the engine and release to test. So I'm going to talk a little bit now about the test program that we've got lined up for the engine. I'll talk a little bit about the technical progress that's been made over the course of the last month or so. I'll give you an update on the parts that we've been manufacturing, and I'll also give you an update on the production equipment for the various parts of the engine that we've been procuring and have been arriving here at DC1. So the way that we're going to test or do the development testing of the engine. So this is the testing that just proves that the engine works. There's obviously a plethora of certification testing that comes later, but this is how we're going to get the engine to the point that it runs and it works and we've proven that it's reliable. The first stage of testing will be essentially to test the starter generator and the mechanical drivetrain that takes the power from the power turbine, reduces it down to 6,000 RPM and then squirts it into the main rotor gearbox. And the reason for that is those components are actually the bits that are furthest advanced within the manufacturing cycle. So I'll show you later that the actual flying components, the bits that will fly in the prototype aircraft, are being made at the moment for the drivetrain, and we expect to have those components on test over the coming months. So the first test will be get the starter generator working on a bench and test that. The second test will be to have 2 of the engine drivetrains running on a bench. This will run through the entire operational range of the engine, but then it will also go on and do the full 5,000 hour endurance proving runs to demonstrate that those gearboxes will work throughout the entire life of the aircraft. The second test is then to take the starter generator, the compressor, the diffuser, the combustor, and perform a light-off test. Prove that the compression system works at the lower parts of the operating map, and that we can physically ignite, sustain stable combustion, and run stably at in the early stages of starting. Once we've done that and we've proven that the combustor works, the fuel system works, the igniters work, the compressors work, and the bearing and lubrication systems work, we then pop the gas generator module onto the back of the engine, and then we essentially have a jet engine. That allows us to run the whole gas generator module throughout the operating range. It'll function at that point like a jet engine rather than a turbo shaft, but it allows us to qualify the main working core of the engine. The next stage is then to attach the power turbine, attach the drivetrain that we've already proven, and then you have a full GT50. And this is the program that we're working through at the moment. So we're building the components for test on the engine drivetrain. We'll be releasing, I'll show you shortly where we are with releasing the other components for the gas generator section, and the equipment is now here to build those parts. So if we just talk about the 2 core elements of the engine for the moment, on the gas generator module, so that's your compressor, your diffuser, your combustor, and your compressor turbine, and all the associated secondary air systems, this is now very, very mature. We've got a compressor that is essentially frozen, both aerodynamically and structurally. We've got a high pressure turbine, a gas generator turbine that's aerodynamically frozen and pretty much structurally frozen now. There's one last little natural frequency we need to move slightly, and then that's done. We've already built the first demonstrators of both the compressor and the gas generator turbine. The combustor is essentially frozen aerodynamically from a thermals point of view, from a combustion point of view. We have one small tweak to make to the back end of it to allow for some extreme cases of thermal expansion, and then we'll be starting building that immediately. I'll show you shortly that all of the production equipment we need to build that is now here, and the materials here to build that as well. So the combustor will be coming to life very shortly too. And then the power turbine that you can see at the back of the engine, again, I'll demonstrate that we've built the first demonstrator for these components. We're just waiting for the structural optimization on the new fir tree roots and a couple of blade frequencies to be optimized, and then that too can be built to get the whole engine running. So one of the things that we've been working on recently, as you're aware, is the move from single piece cast blisks over to bladed discs. So that's where you make the rotating disc and the individual turbine blades separately. Now, the reason for that is fir tree blades have profound benefits for the life and the performance of the engine. These fir tree features, however, are traditionally broached, which is quite an expensive process and it's quite an aggressive process. Modern manufacturing methods, such as EDM machining and wire eroding, allow us to cut these fir tree features far more cost effectively than has been done previously, with a far lower capital investment to actually do this. So one of the things that we've been doing over the course of the last 2 months is developing the necessary processes to spark erode these fir tree features and then validate the geometric accuracy that we can produce them to, the tolerances and repeatability of the process, and importantly, the impact that using this process has on the metallurgy of these superalloy parts. Because traditionally the early versions of these machines would melt and then recast the material locally, which would have a really negative impact on the performance of the material. It would locally oxidize it and cause all sorts of problems. Modern processes don't do that, and so we've been doing a lot of work recently to validate that. We've got a specimen that's about to be sent out today that'll be cut up and examined to validate that we've actually done this. But fundamentally, we've got a process now for making these fir tree roots much more cost effectively that's been done previously, and very, very quickly indeed. So really pleased with how that's coming on. And then if you look at what we've got here, essentially having started with the bladed disc for the gas generator turbine, simple, cheap, but the problem with it is the fact that we have to bathe the core, the center of that disc, in cool air to allow it to maintain its structural integrity while it's spinning at approaching 50,000 RPM. Then the hot blades that are bathed in the exhaust gases from the combustor try and grow away from the blade and create enormous thermal stresses that give you a very, very short life. Now, bladed discs solve that problem by allowing the blades to expand more freely without referring those thermal stresses back into the disc. And so it solves that problem, but it creates another one. What we've had to do is repackage the disc, because the fir tree roots need enough space in the disc to be able to get enough of them around the perimeter of the disc itself. So we've had to redesign the turbine to use fewer but larger blades to leave us enough room for the platforms and the fir tree roots, which is what we've been doing. So we've now completed that work. We've actually managed to deliver about a 1% improvement in aerodynamics, which doesn't sound like a lot, but we were already very close to state of the art anyway. So that's a big win for us. And then on top of that, we get about a factor of 5 improvement in the cyclic life of these discs by going down this route. And we also get much better control of the failure modes. When you're designing turbines, it's very much the failure modes and the burst cases that dominate a lot of the structural design. So by doing this, we get better quality material where it's most highly stressed, and we get to choreograph the failure modes to make sure that you lose a blade before the disc itself splits. So really pleased with how that's coming on, and I'll shortly show you the ones that we've been building. In a similar vein, we've done exactly the same thing for the power turbine. The power turbine has the same problems, slightly lower temperatures, but the blades are bigger and heavier. And so it's harder to get the natural frequencies where you need them, and it's harder to get the structural integrity that you need. And so the guys have been working very, very hard to find a balance between the aerodynamic design and the structural design to deliver that. And we think we've just about done that now. And again, I'll show you what that looks like on the demo engine over here. So again, about 1% more efficient aerodynamically, about a factor of 5 improvement in life, and much, much better failure modes. So let's go and have a look at where we're up to with the GT50 engine build. So what we have here is the current impeller. Again, you've seen us make that over the course of the last few months, so extremely high grade of aerospace titanium. This meets all of the required tolerances. It's both aerodynamically and structurally where we want it to be for the test engine. We've also developed all of the labyrinth seals and the curvic couplings we need to align the shaft. We've gone from our 2-stage cast Blisk gas generator turbine to the single stage bladed disc. So this is the new turbine. You can see the bladed disc in there. We've got a new sealing plate here that also retains the discs in place. And then if you look from the rear here, Josh, you'll be able to just about see the fir trees in there that retain the blades axially. So that's the gas generator rotor, and this turbine itself produces around the 1,000 horsepower that we need to spin the compressor up at 46 to 50,000 RPM. So that's all coming along very nicely. Those components, as you can see, are mature, and the only thing we've got to do is substitute these prototype blades now with the cast ones. The other processes here are completely representative of our production intent. We've now also got the power turbine, the low pressure power turbine. Again, it's moved over to a bladed disc. This has been manufactured using the wire eroding processes that I've just outlined to you. So machined here and then wire eroded. We've cleared the geometrical accuracy that we need for the fir trees themselves, and we're just waiting for the final sign-off on the metallurgy of the fir tree to validate what we've done here. And again, these are the new turbine blades that we've developed. You'll notice a very, very slender, high-performance aerodynamic profile, much thinner than we have started with on the cast power turbine. And then importantly, what you can see behind me is you'll be aware that we've been manufacturing the high-speed reduction gearbox now for some time. So all of these components in here, the gears and the drivetrain components are manufactured here. And this is the speed reduction gearbox that essentially reduces the power turbine output from 36,350 RPM down to 6,000 RPM on the output drive shaft. And so as this thing's whizzing around generating your 500 horsepower, that pops out at the front here to go up to the main rotor gearbox at about 6,000 RPM. So really pleased with how this is coming on. In the interest of doing this demo today, these are our gears, but we've had some cases rapid prototype because we hadn't got enough capacity on the 3-axis, but we'll be replacing those cases with our own shortly. And again, we're then getting ever closer to being able to get a pair of those strapped together and run the endurance test for the drivetrain gearbox. So really pleased with how that's coming on. Literally, as soon as Craig's finished the final life in calcs and that, we're away. We can get that built and get it on the test rig. So, one of the other key areas for our drivetrain, both in the engine and also in the main rotor and the tail rotor gearboxes, is bearings. Now, we get asked all the time, why on earth would anybody try and make bearings? It's purely down to economics. There's a helicopter tax, if you like. When people know where they're going, the prices become completely intolerable. So we've had no choice but to develop the means to make bearings. Over the course of the last few months, we've been developing the processes, the handling, creating the kinds of controls in the manufacturing environment we need to be able to do that. And today, I can report that we've successfully completed all of those steps, and Hill Helicopters can now make aerospace grade bearings right all the way up to the 50,000 RPM bearings that run in the engine, down to the low speed, more commodity units that we use in the main rotor transmission and elsewhere in the helicopter. With the equipment we have here, we are hitting the tolerances repeatably to make these bearings. We've also now pulled together all of the remaining bits of equipment that we need to be able to super finish the raceways. We've identified that kit. We've got a subcontractor to do it for prototyping, and we will buy the equipment for production. So the raceway super finishing has also now been developed. And in terms of the first bearings, what we've got here, this is the first gas generator bearing that we've produced. So this is one of the bearings that is most expensive to purchase externally, and we've now hit all of the tolerances that we need to in producing these bearings in-house. So really pleased with how that's coming along. So let's just talk similarly about the aerospace grade gears. You've watched us over the course of the last year or so develop all of the processes that we need to develop to be able to make gears from high quality certified material that are fit for use in a certified helicopter. And helicopters are far more machine than they are aircraft. So being able to make these mechanical components is the essence of any helicopter manufacturing company. And again, what we can report today is that the work that we've been doing in terms of prototyping the gear, so using commodity CNC machines and very, very careful process control, we have now got to the stage where we can make hardened aerospace gears to the required process controls that hit all of the tolerances. So we're absolutely delighted for that. And if you just come over here, what I will show you is that the gears that are going to go flying in the GT50 engine and in the main rotor gearbox of all of the prototype aircraft are now being produced. And I can also show you the metrology reports that show that every single one of these gears are hitting the tolerances. So the first stage in this process was to develop the overall main rotor transmission, the engine drivetrain, and develop out all of the gears that we need to make that system work. Behind the scenes, Mark, Mick and his team have been developing all of the sophisticated process control that you need to be able to make all of these gears repeatably to the tolerances that you need. And what we've got here is the batch of gears that are actually going on fatigue test to validate the life of all of the gears that we use in the aircraft prior to running the big expensive tests on the whole aircraft drivetrain. And if you have a look at any one of these reports, you'll find that every single parameter in terms of cylindricity, roundness, flatness, profile, surface finish, run out, all of those exceed the requirements for any of the existing certified helicopter manufacturers. So in the space of just over a year, we've gone from procuring the equipment and the personnel to do it, developing the processes to work at this level, and then delivering repeatably and reliably aerospace grade gears in the right materials to the right standards. What you can see in front of me here is the fledgling batch production for all of the components that will be going flying in and doing the bench testing on the ground for the actual prototypes. These components here are for the speed reduction gearbox that I've just shown you, and they're being closely followed by everything that will be required for the main rotor gearbox and the tail rotor gearbox. So Hill Helicopters can make aerospace quality gears and aerospace quality bearings repeatedly with what we have around us here. So good news. Okay, let's talk for a moment about the digital cockpit. There's been an awful lot of work going on over the course of the last few months, really, that we've been updating you on periodically. The main focus of this work has been moving over to target hardware, implementing real physical hardware, and getting our software fully developed out. One of the big things that we've been focusing on recently, working with our control partners and the in-house team, is the development of the FADEC system. So the FADEC system gives us that ultra-tight RPM governing of the main rotor speed. It gives you the easy start and stop functions on the engine, carefree handling of what is a very sophisticated gas turbine engine. So where we've got to over the course of the last month or so is we've now fully developed all of the FADEC control laws. So these are the algorithms that tell the fuel valve what to do to manage the RPM the way you want it to. We've integrated the FADEC with the digital cockpit, and we've also integrated the FADEC with our engineering simulator so that we can fly the HX50 in a virtual environment and explore how the FADEC system is going to behave in different regimes of flight. What we found is we've got absolutely outstanding performance. So with 0 to 80% to 0 to 80% to 0 to 80% in about half-second periods, the rotor RPM doesn't droop by more than about 0.5%. So it is extremely tightly governed. Now, we've obviously got to prove this out on the physical engine, and that performance might move around a little bit, but overall, with the fast-acting electronics, the fast-acting fuel valve, and the very short time constant that engine's got when you take into account the anticipation functions that are built into the control laws, we have an incredible engine management system for you. And we'll talk a little bit more about that with Eric shortly. One of the other big areas that we've been focusing on, of course, is pushing all of the user experience onto target hardware. The initial development of the user experience was done based on a PC platform to allow us to quickly and flexibly develop, but we need now to put that on target hardware, so little circuit boards and processors that we can package and meet all of the environmental certification requirements to go in the helicopter and then take that flying. So Eric has now ported all of the DigiCockpit software onto target hardware, and we have our user experience running on our target hardware that is essentially now very close to being able to go flying. There's still some software stack development to be done for HC50, so taking that all the way out to certified graphics drivers, real-time operating systems, and those two programs will merge before production. But fundamentally, we can now run the DigiCockpit on target. It's been a very big and demanding job, and Eric will tell you all about that shortly. In other big news on the DigiCockpit, we've also expanded the software development team. Ganesh has joined us, and Zenu has joined us on the electronics side. And this has basically allowed us to push forward on a number of areas. The power electronics that drive and control the starter generator is being developed by Zenu, and then the integration of all of the third-party peripherals, your radio, your transponder, your GPS source, your audio panel, and a bunch of other things is being developed out by Ganesh, while Eric focuses on the target hardware piece. So the next step essentially is to get those devices under UX control. But for now, let's go and have a look at what we've actually implemented on the DigiCockpit test bench. Hey, Eric. So,
Jace.
Target Hardware, you've got it to work. Why don't you tell us all about it?
Yeah, absolutely. So, as you mentioned already, before we've been just running and developing things on desktop, which has a lot of performance, a lot of compute and graphics performance, which is great for just getting things working quickly. However, it's not an accurate representation of what we'll actually be able to package in the helicopter. So we have our strong candidate for our hardware here, which is a popular choice in the industry for both its graphics and compute performance, as well as a path for safety certification, which is important for us. And so over the last few months, I've been working to port the software stack that we have to this hardware, which is technical on many levels, both from a compatibility level, but then also performance constraints, as you can imagine, are a lot different for the target hardware. So there's been a lot of low level, like dealing with graphics drivers and between the hardware and its architecture and our software stack. But now that we have that deployed, now we can actually start optimizing and measuring our performance relative to what's needed for the helicopter in terms of frame rate, in terms of all the other things that are important for delivering a safe and usable interface for the avionics.
So that looks good. What are the next steps from the Target Hardware point of view? What have we got to do to take this all the way up to where we need to be for HC50, where it's all fully certified?
Yeah, so there's a lot to do, obviously. This is a massive step, however. Being on target for this allows us to actually know what we're working with from a hardware perspective. Yeah. We actually can measure our performance and compare it to like what's needed. And so now that we have an idea of what we're dealing with, we can optimize it. Because up until this point, we've just been more or less just getting things working. But now that we're on target, we can start refining and optimizing the code base, the application from the software level, and refine it so that we're actually so that we're meeting standards. We're already doing really well. In fact, I can just get this running here on the simulator, and you can see this screen right here. Yeah. On the PFD. That is running off our target hardware right now. So you can see frame rate is already great. We're also controlling the radio and the intercom already off of target with this. So all of that is working, but there's a lot more we can do just to improve performance from a graphics perspective, and also for the other interface applications with the other systems.
So I mean, it's because you look at this all day, every day. Right. But I mean, from my point of view, I can't perceive any difference there. And I know Martin's the same between where we are with this and where we are with the PC hosted version. So I mean, it works really well.
There's some subtle differences, but yeah, it's looking really great already. Other than that, we have just a lot of just going through and doing a lot of testing. We've been very much in a prototyping stage, just getting things functionally working.
Yeah.
But obviously for something that's going to be in the air flying and has a lot of safety certification aspects to deal with, so we need to go through everything and really refine that structure with an eye on certification and the steps needed to go towards that.
Fantastic. Well, I think you've done incredibly well. It's a great job. From my point of view, it looks incredible. It works really well, and it'll only get better from here. So Thank you very much. Well done. And I know everybody's going to thoroughly enjoy flying behind this, because it's incredible. Fantastic. Okay, so when I look at this picture, in some respects it seems like a whole lifetime ago. But since this photo was taken, we've engineered HX50, we've engineered GT50, we've engineered the digital cockpit, we've vertically integrated the entire supply chain for making general aviation aircraft. We've sold aircraft in 59 countries and got a 56% market share, and we've built, more importantly, a global network of people that feel really passionately about helicopters and about general aviation. Now, I'm stuck in the weeds of this all day, every day. So most days I've got a range of technical problems on my desk. But some days I come to work and something magical happens, and you suddenly realize just how far you've come. And this happened earlier in the week, this week, where I got a phone call from Dave, and he said to me, "You've got to come down to DC2 because we've finished the tail boom and we've built the first full fuselage for HX50 and it looks absolutely incredible." So I jumped in my car and I went down to DC3 and there it was. Let's go and take a look at it. So this is the very first full fuselage for HX50 and the cameras won't do it justice. It is absolutely massive. We promised you that we were going to design a proper helicopter and that when you bought your helicopter and when you flew your helicopter and when you were around your helicopter, it would feel like a proper helicopter. And this really does. So we're presenting it here today with all of its cowls off. It hasn't got any of the engine bay covers on or anything, no doors, but even so, the lines are exquisite and you can really start to see that we've delivered on what we said we were going to deliver. I know some people out in the public have bemoaned the fact that by the time we get through development, it won't look like that. The images that we created and we put out as part of our marketing campaign were taken from the same CAD models that we built the patterns and tools and designed the structure around. So what you see is what you get, and here it is. So if you look at the size of it, the other thing that you need to look at with this is based around Fuselage 5 that I spoke of earlier. And so one of the things that you can see here as well is just how rapidly we've refined the process for manufacturing the aircraft and for manufacturing aerospace grade composite parts. The surface finish on this airframe is far better than any of the ones that we've done to date. The detailed features such as the recesses for the doors and windows is absolutely perfectly presented. We've got all of the B surfaces in, so all of the foam cores are in, all of the B surfaces in. We've got the refined laminate book in here, so it's a much lighter aircraft. This whole thing is about 80 kilos, 75 to 80 kilos. So two people could easily pick this up as it stands here today. So it really, really is a fantastic testament to just how far we've come. With the tail boom on, you can see the key styling features of the line that comes all the way down the midriff of the fuselage that gives it that stance. You can see the general space of it, the space of the baggage bay. I've not pointed out previously that part of the maintenance and the inspection strategy for HX50 is that everything sits on this engine deck. So Josh, if you want to just come down here, you'll get a better view of it. I'll go behind actually. What you can see here is we've got a flat deck buried underneath the cowlings where the main rotor transmission sits on the roof. The engine sits in this bathtub here, and all of your drive shafts sit along the top of the airframe under the covers here that are easily accessible. So we've got a really, really easily maintainable helicopter where once you've got its cowls and its covers off, you can get at everything to inspect and everything to maintain without having to undo millions of screws and take the thing to pieces. So this is the first glimpse you'll get of that. One of the other features to point out as well is we've engineered a much deeper ducted fan duct. This essentially allows us to get about 20% more tail rotor thrust for the same amount of power consumed. So it's a big step forwards. We've also done a couple of other minor tweaks around the geometry of the tail fin as we've gone through development to improve performance and improve the general presentation of the aircraft. But after waiting sort of 25 years of my life, it's been a pretty amazing week this week to see this for the first time. So, just grab my mouse. So I've just got to have the presentation back. There's a couple more slides to go through. There we go. So just a quick update on a couple of other little features. Over the course of the last month or so, sales have continued to be very strong. We're now up to 830 sales with 673 X's and 157 C's. So again, If you really want one of these there's no time like the present, because the further we get down the development route, the more potential we're going to unlock within our vast sales pipeline. So anybody that's been watching us for a while now, this thing's getting real. You better come and join us. Another bit of good news for people is we announced a little while ago that we will be unveiling the HX50 at the Imperial War Museum at Duxford on the 6th and 7th of December. The 6th is for customers only, and the 7th is open to the general public and the press, anybody with an interest in HX50. When you come to the event, you will be able to experience HX50 for the very first time. You'll be able to sit in the seats, you'll be able to see the lines of the aircraft, use the digital cockpit, and experience what it's going to be like to own one of these for yourself. You'll also get to experience the GT50 engine for the first time, and the fully functioning digital cockpit operating on target hardware. We'll also be rolling out the drivetrain and the rotor systems, and of course, as with all of our events, you'll be able to network with our team, the people that are bringing this whole program to reality, and also with the large global community of owners that we've developed around the world. So we very much look forward to welcoming you to Duxford in December. So on that point, I'll pause, take a breath, and welcome any questions that you might have. I changed the backdrop to my question slide just to give the sense of scale to HX50. So I thought I'd pop a car in there so that you could see just how big this aircraft is. So there you go. I'd be happy to receive your questions.
Amazing, Jace. What another incredible update. Very exciting to see it come together and to see that full aircraft sitting behind you. I can't wait to sit in it, actually. It's going to be pretty neat. I was just over there with Ruben a couple of weeks ago, and we got to see the airframe part of it, but the tail boom wasn't done yet at that point. So I'm very excited to be there and see that in person, because I know it's going to be amazing. We've got lots of questions here today. You guys did very well with your questions. By the way, keep them coming. If you haven't posted your question yet in the chat, we're going to try and get through everything that we can here tonight. So make sure you keep posting those questions in the chat, and we'll present those to Jason. So the first one, Jace, is from Kenneth. And his question is regarding screens in the aircraft and the usability of those screens while you're in flight. So I'll just kind of summarize the question because it's a long one. But basically, first of all, maybe touch on the main displays that we have. So the pilot and the co-pilot's displays. And then a little bit about the iPad. And the specific question is about when you're using them in flight and your hands moving around and so forth, using a touchscreen can be difficult. So do we have anything kind of built into the aircraft that you can rest your arm on to make it easier to be able to use that iPad, specifically the iPad in the middle, but then also the other display screens as well?
Absolutely. This is something that we think about all the time. So fundamentally, all of the things that you're going to need to do all the time, put in a altimeter setting, change a frequency, use your audio panel, put a transponder code in, that can be done with your arm on the armrest, with your hands supported by the little ski ramp that runs up to the IPI, and you can either type or push those big buttons on the IPI using your forefinger when your other fingers and your thumbs are clamped on the finger rests around it, or you can equally input that information using the PUC. So the PUC allows you to select and put numerical values in. When it comes to things like radio frequencies, all the radio frequencies are pre-programmed, so you can just flick through the PUC and it will go through every station in your area until you get to the one you want, or you can just use it like a conventional radio knob as well. So we thought a great deal about those sorts of features. In terms of the touch screens in the big screens, yes, they're all touch, but they're, again, at the top, the visor that sits on the top of the screen is just deep enough so that you can hang your fingers over the top of it, and the only function that you would need to do along the top is to prod at things with your thumb, with your fingers fully supported. So you've got your ident button, you've got your monitor function, you've got your swap functions for all three radios, and then of course we've got Eric's swipe to swap function that again you can do with your thumb. So all of that's handled. If you want a shortcut to a particular page on the IPI, for example, to put in a pressure setting for your altimeter. You've just got to hit anywhere on the altimeter. And the same with putting your autopilot features on. There's another ridge along the bottom of the screen, so you can rest your fingers on the ridge and then just poke the autopilot modes with one unsupported finger. So we think we've got that. I mean, I fly helicopters with autopilots and things like that, and you only need a little bit of support to be able to do that under typical circumstances. So we think we've done a good job of that. The proof will be in the pudding when we test the prototypes. In principle, it works well on the human factors rig. It works reasonably well on the avionics rig over here. We need to go and shake it all around a little bit to see how well we've done that, but we think we've got it covered.
Great answer, Jason. And the second one is also from a different Kenneth and Eisner. And he has a kind of a funny but important question. It says, every time I see a video of Jason driving his car, it's rainy and overcast. Do you think we'll be able to build a flight training in 2-week period?
Yeah, you'll just be very good at flying with inclement weather conditions like we are. So yeah, sometimes the weather's challenging. I think for basic flight training ops and things like that, it's not very often that you're totally grounded all the time. So it's not we don't anticipate that being a massive problem.
But the build is done in-house, right, Jason? The build is done in-house. There's no problem. The build is done in-house, right?
Yeah. It's not going to impact the build. It's just the flight testing and the type rating training. But again, if that becomes a problem, there's some obvious ways we can solve that by providing training elsewhere where it's a little sunnier. So there's lots of things we can do about that. We'll react as we need to.
Good. And Paul is asking from Norway just about CFG limitations. So he says, I'm 140 kilos and 185 tall. Can I have a person weighing kilos next to me in the cockpit and still be within the center of gravity?
I'd have to check. So we've got an extremely generous CG range. So you can put 2 people in the front that are seat limit weight and still be within CG. At both fuel conditions. I'd have to go and check how much you could put on the back seats with those particular figures. I can't do that off the top of my head. But it's a far more generous CG range thanks to the essentially articulated rotor system and the trim tank solution than you'd be used to. So if you can do it in a current aircraft, you'll be able to do it in HX50 is what I'd say at this stage.
Okay, Chris is asking about actually, the question is, I think it's sales related, but I'd like you to answer it, obviously, Jason, which is, how much is the baseline and how much is that fully loaded one? That fully loaded one, I'm not sure what he's referring to, but what do you think, Jason? What is that fully loaded one?
When we set the specification for HX50, I wanted the entry-level aircraft to be everything that you could ever want from a helicopter. Now, there's always people out there that are going to want fancy paint jobs and the best of everything and every option you can imagine. The baseline price comes with leather seats, climate control, the digital cockpit. It comes with a 2-axis autopilot. It comes with your environmental control system. I think I've already said that. Retractable undercarriage, any paint color that you want that's in the configurator. So pretty much everything that you could want. If you want to go and specify extra radios, or if you want to specify synthetic vision, or if you want to specify heated seats, or other more obscure features like that, then those are options. The 4-axis autopilot is an option, but you don't need a 4-axis autopilot. It's just your choice whether you want the safety enhancements of it. So my view to you is you could happily have a base model, and nobody other than the world's geekiest HX50 geeks would be able to tell the difference. And from a VFR recreational flying point of view, you don't need any of the options. You've got everything you need in the base model.
Okay, excellent. Good answer. Ken is asking a question about the production and the timeline. So he says, since you haven't broken ground yet on the factory, do you still think that deliveries will start at the end of 2024? And could you estimate a date for building the first one and what the pace will be going forward from that?
So we're working a lot on that at the moment, as I've hinted at in some of the customer updates. I'm limited in what I can say about the factory because it's going through an approvals process at the moment. I don't want to prejudice it. The timelines haven't changed. As it stands at the moment, we are still on schedule for end of 24. The way we're dealing with the factory is there will be the factory capacity is being designed to be slightly higher than the 500 a year, so that we can ramp up to that over the course of the year, allowing us to build parts stocks first, sub-assembly stocks first, train the staff over the first 2 to 4 months that the factory is operational, and then pick up the pace as we go through the rest of that first year of production. I mean, as you can imagine, at the moment, we're still developing the production processes for parts, and so there's a lot of detailed information that needs to go into that for me to be able to tie down exact dates for how long those first stages of production scale-up will take. But nothing's changed in the plan. We're still on track as I see it. We don't have a lot of time left in terms of further delays with planning permission. So again, I'm limited to what I can say publicly, but we're doing everything that we can to make sure that we're not hung out to dry by that process. So yeah, at the moment, I'm still robust about the time scales, but we'll keep reporting back where we are with that honestly as the situation evolves.
Colin is asking, have you selected a test pilot for the early flights?
No, is a simple answer. There's a bunch of people that have made themselves known to us that are graduates of the Empire Test Pilot School, and they need to have the right credentials from the CAA and be in favour with the CAA at the time that we're going through our initial type approval. So I haven't done anything to effort that yet, but I have lots of offers. It's the job that you wouldn't think you'd get any applications for, but we have lots of offers for test pilots. So yeah, no, we haven't appointed anyone for that yet.
Okay, Manuel is asking a question about, due to its light weight, is it still safe if it crashes? Oh,
it's very, very safe when it crashes. One of the things that I wanted to do for the update, and with everything that's been going on with the tail boom and whatnot, we haven't had a chance to, is I wanted to do a little video jumping up and down on the roof of fuselage 4. So you can see just how stiff and strong these carbon structures are. A lot of traditional helicopters have a sort of steel frame and then a cantilevered fuselage structure, and the covering for the canopy is essentially just aerodynamic fairing. It's not a significant contributor to the structural strength. The beauty of the monolage is that you've got a roll cage that is the primary loading structure. It's those beams that come down in between the doors along with the fuel structure behind the cabin that carries all of the lifting loads. You don't have an overhung floor in the cabin that's just cantilevered off. So we have a shell that is inherently stiff and strong and crash resistant, and then within that we've got the stroking seats, and then we're just developing out some of the additional energy absorbing members for the floor to support the really high impacts. So we've got a structure that easily carries all of the loads it needs in a crash to hold on to the heavy bits, which is the thing you usually worry about in helicopter structural design. So making sure the gearbox and the rotor stays where it's supposed to and the engine stays where it's supposed to. That is not difficult to do. Containing the fuel, because it's in the heart of the strongest bit of the structure, then we're in a really good position with the bladder tanks and protecting those. And from an occupant point of view, you're in a very, very strong crash cell. I often remember there was another helicopter program where they had a mishap during development over in New Zealand, and they lost phase control on the swash plate and had to bring the helicopter down, and it rolled over. And the performance of their structure, which was also composite, was absolutely amazing. And the thing just looked like it was having a little sleep. It didn't look damaged at all, and that's the kind of level of performance you'll get from our structure as well. So it's very stiff, it's very strong, and I'll be quite comfortable trusting my family in it. So don't worry about that, that'll be okay.
Excellent, very clear answer. Steve Buchan from Canada. Hi, Steve. He's asking,
Hi, Steve.
Off airport landing, how do you lock the wheels prior to landing? Where are the settings?
Those settings were originally on the center console, so that you've got an undercarriage switch that would deploy with the brakes on, and then there's a separate switch, setting on the switch where you can deploy the caster lock. We've actually just moved those settings onto the roof panel, and the reason for that is we didn't want to have a great big hole on the center console for the people that bought skidded helicopters where all the switches were missing. So we've moved that to the roof. So your nose lock and your undercarriage deployment are now on the roof panel. And that as you probably saw when I was in the HF unit, everything on the roof falls very conveniently to hand. So you have your rotor brake up there, and you'll have all of your undercarriage controls up there.
Okay. James is asking, all looks very brilliant. When will a helicopter be available to buy, fully manufactured for personal use?
I don't know what the latest slot is. When's the next one available? That's a question for you guys.
Yeah, so 673 aircraft. Yeah,
Right.
673 is where we've gotten to today. And so we are estimating delivery of these next aircraft to be about this time of the year in 2026. So like Jason mentioned earlier, he's going to be building about 500 aircraft in that first year. And so since we're at 672, we're looking at about 3 to 4 months into that next year. Okay.
Okay,
Go ahead with
right.
the next one.
Excellent. Yes. So to add to the similar question regarding the ability to lock the landing wheels, a little bit of more of a further question on this part here, Jason. Can you elaborate on the pros and cons of wheels versus skids and give some details on the wheels? In particular, how resilient they are to slope and sharp objects. For example, whether they are air inflated or solid.
They're air inflated because you can't carry a solid tire, and we haven't got the time or headspace to develop run flats for aircraft yet. So they're a conventional GA tire. At the moment, irritatingly, we've got a tubed nose wheel and a tubeless main wheel, just because of availability in the sizes. But we may just do a bespoke tire to correct that in the fullness of time. In terms of resilience, I mean, your experience with road vehicles and off-road vehicles talks to how resilient the tires will be to sort of puncture and damage. I don't anticipate any major dramas with that at all. In terms of slopes, again, I don't think you'll notice any material differences. They'll be cleared to the same slope limitation, because the slope limitation isn't necessarily about the stability of the undercarriage. It's more to do with your lateral cyclic range. So your slope limitations in practice won't be changed. I think I've mentioned on these updates before that of the sort of experienced Army pilots that I deal with, that have got experience of both tricycle wheeled undercarriage and skid undercarriage, most of the Army guys will prefer the wheels because, of course, a 3-point landing is statically determinate. So you haven't got that fourth leg that's just going to wobble. Whereas on skids, you're always going to be teetering on 4 points. And so for harder ground and even harder ground, I think the wheels would be a better option. We've discussed previously how for operating at your home base, operating at airports and things, wheels have a profound advantage for moving the thing around on the ground, plus the addition of HeliMove. So in terms of slopes, I don't think you'd notice a material difference. Steve, for some of the backcountry flying that you like to do, the only thing to think about is obviously there is a limitation to how you can land on really soft surfaces like powdery snow and riverbeds and very soft ground. So you might want to be mindful of that. We will provide a bare paw kit for it that's pilot removable, so you can just put it on and leave the gear down when you go into those kinds of locations. But fundamentally, for me, I think the wheels are the better option. Though I do regrettably acknowledge that the skids look cool.
They look pretty cool, Jace. But I'm going to still be having the wheels for mine, so I'm going to be landing in the same type of terrain that Steve is. I'm just going to have the bare pocket for mine for those winter flights. Carl is asking a question about the impact-resistant windscreens, and will they be able to handle the impact with just the bonding, so without He just recently got a Robinson 66 with the impact-resistant windows, and they have to be bolted on, as I'm sure you all know. And so will these be able to be just bonded on? Will that be good enough? And then he's hoping that that's not going to affect the cleaning of the windscreen just because of all the rivets or the screws that have to go into that.
So I picked the question up on the app, I just haven't had a chance to respond to it yet. So we're doing everything we can to avoid fasteners in the windscreen because they're horrible in every sense. If we do need to do it, then we will do it with finisher pieces that bond over the top of them. So there'll be a joggle formed into the windscreens, and then the nose beam, there'll be the body coloured nose beam that runs down the centre of the nose will have a finisher on it so that you can keep the flush surface and hide the fasteners and something similar around the window. So we're doing everything we possibly can to avoid that at the moment. Technically it's possible, but it's not easy. So as I said, the reason why we've been pushing this window stuff recently and the frit and the bonded strength stuff is because we need to get a little bit more out of that bonded joint to make that work. So we don't end up with massive thick bonded joints to meet the requirements. So it is technically possible, but it's difficult. And if we either run out of time with it and have to make a decision, or we simply can't get it to work with bonding, then we'll just joggle the fuselage so you don't see it. So you'll keep your flush exterior. I won't make a mess of your helicopter, and it will be nice and easy to clean.
All right, Giuliano in Canada, he's asking for us in Canada, and I'm sure that in other cold weather countries too. When there's ice on the ground, the trolley that pulls the heli into and out of the hangar needs to have some kind of anti-skid on them, like steel cable or chain. Have your people thought of this, and are they thinking of a way to install some kind of snap-on anti-skid belt on the wheels in order to have the heli move system work when the ground is icy?
I am now. So I hadn't thought about it, no.
Thank you, Giuliano. That was great.
Thank you.
Yes.
Yeah, I'll buy you a coffee for that one. Yeah, we'll have a look.
We'll
have a look
at
at
the
that.
community, right?
It is. In any product development, there'll always be corner points. There'll always be things that you haven't thought about. It is the power of the community. So that's noted. I hadn't thought about it. We'll think about that and see what we can do. If you can do it on heli movers, you can do it on HeliMove. We've got some room in the wheel well so that you could leave those things on if you needed to. So yes, we can accommodate that, but we've done absolutely nothing about it yet.
Okay. And on a similar vein about the wheels, so David is asking, what type of wheels have you developed for the skidded model? So obviously the removable wheels.
We haven't developed any wheels for it yet. It's one of the things that's still on the jobs list. They'll just be over center wheels for the time being. So we'll look to do something a bit more sophisticated later, but at the moment the skid option comes with utility, but a slight lack of convenience. Better have normal wheels.
Okay.
Next question, is the iPad supplied or included? And also, what about the Bose headsets? Yeah, the Bose headsets, that was one of the things that I regret putting in the contract as standard, because it is in the contract and it is included and they keep going up in price. So yeah, and the Bose headsets. You don't manufacture them, right? That's no, I don't manufacture those. I'm gonna. But no, those are included, unfortunately for me. So they're really good. We like them a lot, and they are included. So. But for the iPad, the iPad, store, right? The iPad's not included. No. Again, that's part of a. It's a practical point and it's a philosophy point. The philosophy for the digital cockpit is that the only things that are part of the aircraft are the things that will never change with time. So the requirements for your airspeed indicator don't change as the aircraft becomes 10 years old, 20 years old, 50 years old. The same with all your primary flight instruments, with your engine management instruments, but anything to do with data, anything to do with connecting with the outside world changes all the time. And so the idea of relying on electronic flight book apps and iPads and independent hardware is that that's free to evolve as society evolves and it doesn't age the aircraft. So, and the other practical point is that people will use their iPads for different things, and you wouldn't necessarily want me to buy an iPad that's of the size that suits me for HX50 to suit the other parts of your life. And the whole advantage of an iPad is it's with you all the time. So you do your flight planning when you get the call that you've got to go somewhere, and it's always there. So yeah, you've got to buy your own iPad.
Okay. Sounds good. Just a fun question from Derek. It's not really a question. Can you install a nice espresso machine in the back of the aircraft? That would be nice.
We've been asked to install all sorts of things in the back of the aircraft, so we won't do it as standard. But I'm sure there are people that will do aftermarket things for that.
Joe is asking a question about, do you have any updates on getting this aircraft onto Microsoft Flight Simulator or X-Plane?
I personally don't. I know we're doing an exercise with X-Plane at the moment. I don't know if you can speak to that, Misha.
Yeah, so we are definitely in the development of that right now. X-Plane will probably come first, and then Microsoft Flight Simulator next. But we do have all of the model. Actually, I just got shown that not too long ago, a couple weeks ago. We have the model actually ready for X-Plane now. And so it's basically all the flight dynamics that need to be fed into that to make sure that it actually acts the way that it should when you're flying the aircraft on simulators. And so that dynamic information is getting inputted now as well. So I don't think we're too far. We don't have a date yet, but I don't think we're too far away from being able to have this aircraft, probably later this year, having the aircraft ready to be on both X-Plane and Microsoft Flight Simulator. So
yeah, I can add something to that in that the flight dynamics that we're actually using as part of the development program that are going into our engineering simulator will be done in the next week or two. So the actual flight dynamics consistent with what we're using will be available shortly as well.
Okay.
So that should be pretty nicely configured.
Okay.
A fresh update for the simulator. Norman is asking head clearance from the rotor blade. Is this going to be problematic? He's asking about regarding safety.
Depends entirely how tall you are. So the helicopter has a 5-degree forward mast tilt, and the reason for that is so that it flies very level. So you've got a comfortable level cabin attitude in cruise, and so the mast height I think is currently it's either 3 meters or 3.2 meters. I think it's 3 meters currently, which means that down near the front when the blades are rotating slowly, it could potentially be a head strike issue, particularly if you're on a windy day. So like with things like the 109s and some of the sleeker helicopters, you will have to be careful to approach from the side and to advise your customers accordingly. It's not crazy low, but it's something to be aware of for tall people. So the normal safety measures that you'd take in operating around a helicopter apply.
Okay, sounds good. Next question is from Daniel. Before that, we have another question from Don. I'm just going to touch on that really quickly because I just ran some math here. He was asking about weekend flying. So if you're looking at weekend flying, he's estimating about $50,000 a year on fuel costs. He wants to know if that's a realistic number. So I just did some general numbers here. The helicopter burns 35 gallons an hour. And so if you're flying at about 70 hours, let's say in a year, 35 gallons an hour at about $8 per gallon, then you're looking at about $25,000 on fuel. So obviously that'll fluctuate around the world, different fuel prices and so forth. So just a note on that. But the question from Daniel is about, have you removed on the starter generator, have you removed the shaft in the front of it?
Have we removed the shaft in front of it? The drive shaft, so the shaft that runs diagonally up to the main rotor gearbox. If that's the one you mean.
I'm not sure. So the starter generator, maybe connecting to the engine. I'm not sure. It's hard to say with the question. That
okay, so the gas generator shaft that we saw on the engine rig over there is a self-contained shaft, and then there's in fact, let's do it over here, Josh. Position yourself there. So the gas generator shaft runs from there to there, and then there's an additional stub shaft that plugs into the end of the gas generator shaft that's a totally different diameter and has got a floating spline connection so that it decouples the rotor dynamics, and that's the shaft that drives the starter generator. and the starter, well, that's the shaft that the starter uses to drive the gas generator, and then the gas generator uses to drive the starter generator. So that shaft's still there. And then the main drive shaft that comes out on the bottom of the engine here, there's still the output shaft that goes up diagonally in front of the starter generator to get into the main rotor gearbox. And that has to be there because the height of this shaft is set by the output from the back of this gearbox going down the tail boom to drive your tail rotor, and getting the engine positioned as low in the helicopter as we can to keep the drag to a minimum, give you that nice high cruise speed. So that configuration hasn't changed at all. The distance between those two shafts changed when we revised the gearbox, and the detailed design of the connection between the starter generators changed several times during the development, as you would expect. But the basic mechanical configuration's the same as it has been for about 2.5 years. So no, that's pretty stable.
All right, Simon is asking, I have flown the EC-120 for some time, and although they didn't have air conditioning, they were equipped with a blower fan, which worked very well. Just wondering if you're thinking about fitting the HX50 with a fan.
The cabin has to be ventilated. It's a certification requirement. So there'll be natural ventilation when you're in flight, and there'll also be a fan as part of the air conditioning system. So you'll be able to, like with all aircon systems, you can turn the air conditioning pump and circuit off and just ventilate, or you can have it. So yes, that will be included.
Okay. And Sam is asking if there will be cup holders in the front and the back seats, or at the bunk in the area of the front and the back seats.
There will be cup holders, but we haven't decided where we're going to put them. They were originally based in the seats, but it causes a crashworthiness problem. So they've had to be moved from there. So we'll find a convenient location where they can stow away quite nicely and be out of sight when they're not in use. But yes, they'll be there.
Okay, now we're going to be entering a role of very technical, again, good questions from Xavier. And we're going to try to summarize all of them, and Misha and I, but we're going to start with the first one, which is, could you please talk about failure in critical systems, such as the engine, transmission, rotor system, or control surfaces?
How long have you got?
Yeah, but that's just the first one, okay? Then we have a lot of other ones. So I think it's just commenting in general, what is your approach and the approach?
So if we start with the main rotor transmission, which is the big one, then the main rotor transmission is a very, very, very conventional main rotor design. So a first stage spiral bevel gear set into a planetary stage. We've got the gears and the planets don't share. We don't use the inside of the gears as races for the bearings, so we don't have the risk of fretting failures causing the gears to fail like they've done in some circumstances. We use the very latest strategies for run dry. We've got the very latest materials. We buy the cleanest materials, the highest quality aerospace gear steels that we can buy. Our processes are as per all of the other manufacturers for controlling the production of gears and critical bearings and the design of these gearbox. So again, as I've said on a number of these updates over the years, you have to see HX50 as a greatest hits helicopter. So it's just a collection of things that we know have worked really well for decades, have lots of in-service experience, and have a well-trodden path through the certification regulations. So we're really an organization that's done a Gucci version of a helicopter and then done the value engineering well. There's nothing strange about the way that we engineer it. So the main rotor gearbox is a very conventional design that fully meets the latest certification standards and has been designed with failure tolerance and damage tolerance in mind, and meets all of the safety case and failure probability objectives of the latest edition of Part 27. So the gearbox is very robust. Similarly with the main rotor system, we've got a very, very conventional main rotor system with a bit of clever packaging to be able to keep it within that cowl. Lots of redundant load paths as far as it's practical. Highest quality materials, very carefully designed from a load prediction and a fatigue point of view, and very, very extensively tested before it's rolled out to customers to ensure that the critical parts work the way that they should. In terms of the rotor blades themselves, again, it's a very conventional composite rotor blade design, very carefully tuned structural dynamics, very carefully predicted and then measured in flight test loads so that we can qualify the loads and the fatigue life properly. And then in terms of the design of the composite structure themselves, again, as far as possible, we build in multiple redundant load paths, and the blades are designed to be tuned for stiffness anyway. So there's very few conditions where you're really driving the blade to high structural demands. So that's all in good shape. In terms of the engine, again, it's an engine that meets the latest part ESA CSE regulations, so the latest certification standards for engines. So everything that has been learned about these little engines is embedded in that little engine over there. So yes, there's things that can go wrong in a gas turbine engine. If you overspeed it, there is not very much headroom in terms of overspeeding. You will eventually be able to blow the thing apart. If you overtemp it, you're going to cook your materials. Those are just physical limitations that everybody has to work with, but the materials are of the finest quality. It's been designed by the people that designed these engines for other manufacturers before now, and it's the greatest hits engine. You know, we've just taken the concepts that have been proven over decades and brought them together and done the value engineering properly. In terms of the digital cockpit, then it's a VFR helicopter. How much of that stuff do you actually need to get it back on the ground? I certainly don't need any of it. In terms of the communication of where your power level is, then essentially you've got haptic feedback on a totally separate system to what's being displayed to you. You fly a helicopter by attitude, and there'll be a mechanism of putting indentations for longitudinal cyclic pitch to give you an idea of what your likely speed would be, or what the position of the cyclic would need to be to give you a cruise speed. So we're developing piloting procedures to make it as easy as possible to fly the aircraft with all sorts of things broken. And then the composite structure itself, if you look at the finite element analysis of that structure when it's subjected to any manner of loads, you could crack pretty much any bit, you could delete pretty much any bit, and it would still carry the flight loads. So we're in the envious position with a structure like that that's got such distributed load paths. The damage or the cracks would have to be so big and so large that if you didn't pick them up on a pre-flight inspection, then you probably shouldn't be flying. So you know the structure is very, very robust indeed. So I think that covers most of the important bits. I feel very robust about the safety case. It's all got to be proven out. We've got to prove it on the ground. We've got to incrementally work it through flight test. We've got to bring those loads and those experiences back and qualify the fatigue lives. And then we will fly. I will always have the fleet leader of HX50 and HC50, just as a point of principle. Because when you're offering the warranties that we're offering, we need to know what's going to break before people start finding it in the field, so it can be mopped up over 100 hours and annuals before we have big warranty claims. So no, I'm very robust about that. It's a big job, there's lots to do, but we know what we're doing.
Very good answer, Jace. I think you've covered actually most of the questions that were covered or that were asked there. Can you just touch on the hydraulic system and just how that affects if you had a failure there, other systems? You know, is it going to affect different parts of the aircraft as well?
Yeah, so the hydraulic system is separate between the undercarriage and the flight controls, and again, that's learning from previous accidents where we had an incident where a nose wheel got knocked off and it drained the hydraulic system for the flight controls. So we don't do that. You've got separate hydraulic circuits for the undercarriage where wheels are fitted, and the flight controls. The flight control system is a simplex system. It has it's a dual port system, so it will lock out when the sloppy link actuates, so that you lose the slop and it moves more freely. The control loads are as nicely harmonized as they can be. It's quite a big, quite a heavy helicopter, so it's not far off the limit of what you'd want to muscle. without flight controls. We balance those flight control loads for a nominal operating point as best we can, but it's still going to be a bit of a handful with a hydraulic failure. But the normal principles will apply. You know, a skilled pilot will be able to hover it. A low time PPL will comfortably be able to fly it at a modest cruise speed and then run it on.
All right, and what about cost of maintenance of operation and insurance? So we covered a little bit about that before, but we can give a bit of input on insurance, Jason.
So in terms of insurance, one of the things that the whole point of HX50 is that we're making general aviation accessible again. And as a general aviation manufacturer, we're in a very unique position that we can insure this aircraft much more cheaply than any of our owners can, because we don't need to insure the full hull value. So one of the things that we're doing is developing an insurance mutual that will apply through various channels around the world, which means that we will be able to provide at least your hull insurance. We've got the detail to go through in each of the territories to see if it makes sense doing the liability insurance as well. But fundamentally, we'll be able to provide inexpensive hull insurance for HX50 owners anywhere in the world. And that's because I'm insuring what it costs me to replace rather than what it would cost you to replace. So the hull insurance will be very, very, very competitive compared to what people are paying at the moment, even as a new aircraft.
Okay. And then Randall's asking about, I'd like to hear about the alternator generator, so the starter generator. How during engine failure is this utilized?
Well, it's on the gas generator shaft, so during an engine failure it doesn't do anything, it's shut down. So if he's asking if there's any electrical assistance, then that's something that we are looking at. It's something that we're interested in. We've actually just recruited all of the people that we need to recruit to do that work for us. So we have a background activity going on with more electric and all electric propulsion for HX50. I'm not saying batteries. I can't see it ever being battery powered, but there are things that you can do to make a single engine helicopter much safer with some support from electric drivetrain. So there'll be more on that in the coming years, but that's not something you do with a starter generator. It's completely independent.
So in the event of an engine failure, all of your electrical systems are running on your battery then, is that correct?
Yeah. So the battery has to be sized. Forgive me if I get this wrong off the top of my head, but I think the certification requirement is three starts, so 2 failed starts and then a start, and then you still have to have enough power left for 30 minutes of critical systems after that. So the battery's sized for all of those requirements. Again, that's Martin's area, so forgive me if I've got that wrong, but it's quite a steep requirement for battery capacity.
And next question from Chris says, if the system goes down, does the digital screen go down as well? I'm not sure about what is system, but can you talk about the
so there's lots of
there's
lots of levels of redundancy in this. So you've got independent drivers for both of the screens, and then the data comes in from various sources. So it's not likely, it's improbable that all of the systems would go down in one go. You might have a partial failure, so you might lose a sensor for a particular parameter that feeds both the screens, which would mean you'd have a flag that told you that you'd lost a sensor, and you'd be aware then that data wasn't available or was unreliable. You might lose a screen or a screen driver, or you might lose a connection to a particular screen, but the other one would work fine and can duplicate all of its functionality. You've got backup battery, so you've got generator power, you've got battery power, and then there's also small battery units built into the system so that you can run the screens for a small amount of time if you had a full electrical failure for the critical systems. On top of that, you've still got to have your little LED annunciator panel on the top, just so that you go back to high integrity hardware. So it's very easy to show the reliability of a bulb lighting when a switch trips or a sensor trips. So from a failure case point of view, some of the critical safety features are still alerted to you using very dumb hardware. So I go back to my original point. You've got a very distributed system with lots of redundancy. On top of that, you've then got your iPad that can provide you all of your position data and all of your basic flight information to a level that would certainly get you home safe. And then on top of that, you don't really need any of this stuff in a helicopter. You know, if the situation had got that bad, you would just land it, you know? And there will be fully documented, fully tested and fully approved procedures that cover all of these scenarios. But don't think for 1 minute that because you've got a couple of funky touchscreens in the front of the helicopter and nothing mechanical, that you're in a worse position. You are in a much better position because those components are fundamentally more reliable. And it's much easier to create the redundancy because that stuff's so much lighter than duplicating all the mechanical stuff. Go and have a look at the power to weight ratio of an old twin engine helicopter and all that duplicated IFR flight instruments. They weigh an absolute ton, and we don't have that problem. The solid state stuff's much lighter.
Right. Kevin is asking a question, why is autoclave not being used? A commercial grade autoclave large enough for the helicopter does not seem to be that expensive, and from my understanding they can produce structurally sound final product.
So can our methods, but without the cost. So the problem that you've got with an autoclave is relatively low cycle times, lots of floor space needed for it, and a relatively high cost. And then the aerospace grades of composite materials that go in autoclaves are also expensive. So it's very much, you go back down that road and you're back into the aerospace supply chain again, and you just won't have any control of your costs. Things just get outrageously expensive very quickly. The approach that we've taken means that we're buying materials at the lowest possible price point. We need the least possible infrastructure to make aerospace grade composites, and we're qualifying the materials to the design permissibles that we need to deliver the performance we need to deliver the structural integrity. So we just don't need it. Why would you if you needed it, if you didn't need it? So that's why we've done it this way.
Great. Alice is asking, is the helicopter proportionally longer than the renders?
No, the reason it looks like that, I meant to say that while I was stood over it. If you look at the tail boom, then the tail boom is missing its tail cover. So if you see where it steps up at the end, the tail cover that covers the drive shaft runs along from there forwards. So if you look at the actual top of the tail boom that you see in the renders runs up here. But underneath there, this is just a void where the drive shaft runs and the bearing houses. And then of course up there, if we look at the big renders up on the wall, Josh, a lot of the height of the aircraft comes from the towering pylon and the engine cowls that sit around the aircraft. So if you take those away, it does look very long. This is exactly the geometry that was used in the renders. Nothing has changed except we're on the second generation ducted fan rather than the skinnier one that was in the early renders. But there's lots of good reasons for that. Everything else is exactly the same. We've changed nothing. And if we take, in fact, Josh, come with me again. If I just take you around the back of the fuselage for a second. One of the things that the guys have been doing today is, if you look, we've got all of these little dots, or it looks like it's got chicken pox. We've got all these little dots all over the structure. So the guys have been doing a laser scan of it today, so we can validate the geometric accuracy of the patterns, the tools, all the way through to the final finished product. Because we need that as part of the work we're doing as we automate the production of a lot of this stuff. So we'll be able to tell you shortly just how accurately we're producing these components, but it'll be pretty accurate. We'll be within a small number of millimeters across the full length of it. So yeah, it's exactly the same.
Okay, excellent. How is the tail boom? It's just a quick question. How is the tail boom attached to the fuselage? Brian is wondering.
Josh, stand up again. So there's a break between the structure here, And then we've got metallic inserts in here, buried in the composites, in here, buried in the tail, and then the same on the bottom. So we've got 4 mechanical fasteners that you can get at from the top of the tail boom. So you can get your hand inside the tail boom through an opening in the back here. And in this current version, you can also get into the back. So again, this has just been done very crudely. It hasn't got the, we haven't tapped out the inserts properly. But there's 4 mechanical fasteners in there that you can get at from inside the aircraft, whether you come into the tail boom access or whether you come into the baggage bay.
Tim is asking, what is the status of the new manufacturing facility with respect to the government approvals?
So currently we have been asked to produce some further noise assessments for the area to do with the flying, and also some air quality assessments for the manufacturing facility. So at the moment we've had some more requests for reports and approvals dropped on us quite late in the day. So I'm a little bit frustrated with that at the moment, to say the least. The planners, both within the local authority and our planning people, remain robust that it will get approved. It's a fully compliant bid, but the process is very, very frustrating.
Okay. Terry is asking, can you reveal any solutions?
Backup plans as well, right, Jason? In a positive note, there are some backup plans as well, right?
Yes, of course. I'm not going to be left here with 1,000 orders and nowhere to build them, obviously. So yeah, there's only so much I can say about that. But yeah, we're making sure our customers' interests are protected.
There you go.
Excellent. Terry is asking, can you reveal any solutions to the rotor blade torsional dampening?
There's lots of things that you can do with that, but none I'm prepared to share. So we've got some quite clever ideas with some additional materials you can include in the laminate. But for this first set of blades that we're doing, it will be a very conventional approach.
We had this question a couple of times, but it's always good to have some repeating questions because there's new people on these AMAs. So this question is, does it come with a safety parachute as some small airplanes?
No. So to be perfectly honest, I don't like the idea of a parachute in a helicopter. So a helicopter rotor in auto rotation comes down slower than a parachute. And you've got complete directional control of where you go. There have been some examples out there of people demonstrating that helicopters can be brought down with parachutes, but they're under very favourable conditions. And if you imagine the situation where you'd lost control so badly that you couldn't auto-rotate, you're not likely to be in a condition where you can easily deploy a parachute. There'll be rotors flapping around, there'll be bits of structure that could well have been damaged and be flat. You're likely to just end up in a tangled mess. So I don't currently believe that it adds anything to the safety case. I think having a really robust rotor system, a really robust flight control system, and training people to be totally relaxed in auto rotation is the safest way to do it. And so I think that's a better approach than a parachute. I don't think a parachute's a good idea for a helicopter.
Okay. JT is asking, will it be possible for the HX50 to be converted to a commercial flying, so the HC50, and what would the cost be?
I think you have to assume not at the moment. So it is the same aircraft, but the involvement of the owners in the build process would probably render that impossible.
Okay.
Alejandro, I'm still unclear on the project delivery estimated time for the upcoming orders. I'm in the US and I'm in the US, and so my orders in the 400s. So he wants a bit more clarity of estimated delivery of the 400s.
So for something in the 400s, you're going to be, assuming everything stays the same as it is at the moment, start production end of 24, you're going to be looking towards the end of 25, aren't you?
Okay. That sounds good. And Henrik is asking, at the Duxford event in early December, Did I hear you say that there will be flying prototypes there or not? Did I miss that? And can you give any comments to that? And if so, when? He's basically just referring that to what we had said previously about having flying prototypes basically by the end of this year.
That is still the target. That's what the team are working towards, to have the prototype that will fly there. There is a million things to do between now and then, but there will be aircraft there that you can sit in, that you can experience, that you can use the digicockpit, that you can walk around, that you can take photos of. So full production fuselages with full interiors, with full avionics, with rotor systems, that to all intents and purposes the whole helicopter will be there. If I'm missing a hydraulic servo, or if there's a little component in the engine somewhere, that will make no difference to the experience for people.
Okay.
Hey, Colin, when do you expect the first flight test to take place?
We're still looking around the end of this year. Again, there's no slack in that time scale, so everything that we do needs to work right on plan. So we're still targeting the end of the year.
Okay. The next one's from Ian. I think we covered it, so I'm not going to really ask it. It's just basically an update on the factory, which I think we've covered. So Milos is asking a question. Since this is really state-of-the-art helicopter in its class, have you considered any synthetic devices, simulator for training purposes, maybe even a desktop app, which will simulate interaction with those multifunction displays?
Yes, we have. Yes, we will, but we haven't done it yet. So the X-Plane models and the Microsoft Flight Simulators models will be the first. We will do training aids, and we will certainly do high fidelity simulators as part of the suite of training technologies that we roll out in the future. At the moment, my head is full with trying to make a helicopter, a jet engine, a suite of avionics, a massive factory, and keep all of these things going at the pace that we all want them to. So it'll be something that we pick up later.
Ramon, the question is, any switches on the cyclic?
Yes. So you've got autopilot, force trim release, autopilot off. You've got a plus and minus function to interact with the radio and the selecting comm frequencies. You've got your flip button to flip standby and active frequencies on your active comm radio. You've got a push to talk trigger, and I think that's it on the cyclic. On the collective, you've got hydraulics, landing lights, fly idle, and one more that I can't remember off the top of my head. There's one more on the collective. Those are the main ones.
Excellent. Blair is asking a question. He says, on your interim update, I'm assuming this is on the app, you mentioned that the brow assembly on the airframe up to about its appearance directly in the line of sight horizontally. Is this a relatively easy alteration to achieve? And could the brow structure be eliminated for the front row windows?
It is an easy modification, yes. Technically, it's not a difficult thing to do. We are doing it right now. So the structural members have been trimmed right down as part of the ongoing optimization that's happening. The brow line is going to be tweaked slightly to give an improvement in upward visibility and nose down flight conditions or high rate of climb flight conditions. And I forgot the other part of the question. What was the other part?
No, I think that's pretty much it.
Could it be eliminated? Could it be eliminated altogether? Possibly, but it would cause me a bunch of other problems that we haven't got time for. So it would change a lot of the natural frequencies of the fuselage in that area and cause me some vibration problems that we haven't got time to solve. So I'm just going to make it really small and obtrusive and make sure the rest of the structure works.
Next question. What is the target date for FAA certification?
So that is still pegged for 26. So it'll be simultaneous, CAA, EASA, FAA and Transport Canada as the first wave. So we're targeting
that's for the
mid-26
that's for the
HC50, the fully certified version.
Yes. And Chris is asking, have you completed any crash testing yet?
Not yet, no. So again, so what I say not yet, yes, we have. We've done the impact testing on the crash structure on the stroking seats, or the first generation of those. We're doing a lot of crash simulations at the moment on the structure to optimize the failure modes and the energy absorption characteristics of the monolage itself. The stroke of the oleos has been optimized for heavy landings and so on, and the whole structure has been designed against the crash integrity load, so making sure the heavy bits don't come off and you retain everything where it's supposed to be. So all that's been done. In terms of physical testing, there isn't a great deal of value in doing the crash testing until you've got everything where you want it to be, because one of the big criteria for crash, as well as retaining all the heavy bits, it's importantly retaining your fuel. And so there's a little bit of work left to do on the fuel system to get the bags finalised and the fittings finalised and the connection back to the finished airframe finalised. So we'll do all of that as a suite of tests in one go. But with modern simulation, you can get a very high degree of confidence that you'll pass those tests with only minor modifications required.
Okay, and right now we're 5 minutes to go, so we'll probably have time for another 3 or 4 questions. Terry is asking, can you reveal any solutions on the rotor blade torsional damping?
We've done that
I
one.
think we already talked about that one.
Yeah, we did that one. Okay, good. So next one is, will you be building an XC50 orders before beginning the HC50 model, or will you be building simultaneously?
Both. We'll build them beforehand, and then HC50 is built simultaneously when it comes online in mid-26.
Okay. And Kevin is asking, will there be an option to have a smaller, lower instrument panel as to maximize forward visibility?
No, we'll be maximizing forward visibility by making the instrument panel transparent, using a video feed from the front of the helicopter. So the instrument panel is there because our current cyclic design goes up and behind the screens. So even if you took the screens away, there'd be a load of mechanical kit there to make the cyclic work. So it's one of the trade-offs for having this Gucci cyclic that makes it easy to get in and get out and comfortable for use. Is those mechanical bits have to go somewhere.
Is there a security black box for accidents if it occurs?
Yes.
And John is asking, it's a simple answer. John is asking, will there be a cold weather package like heat pads for gearboxes?
There can be. It's not something we've done yet. So yes, there can be, but it'll be one of the options that gets developed out once we've matured the core of the aircraft.
From Michael, have you made considerations for operating in a maritime environment on a boat or yacht?
Yeah, we have a number of customers with extensive experience of this. So we have a big hit list for things that we have to be careful of: the corrosion, the tie down points, the general handling by inexperienced yacht hands and things like that, and a bunch of other problems that happen on yachts. We'll do as much of it as we can, but there are certain elements of it that only apply to shipborne aircraft. And so those things won't be part of the standard package. But yeah, in terms of tie downs, there's provisions for that. In terms of extensive corrosion protection, that's standard everywhere. And then a number of the other considerations that relate to hot climates and those sorts of things, the covers and all this sort of stuff, yes, we're taking that into account.
Okay. And does the HeliMove, so this is from Tyler, does the HeliMove have reverse?
Yes.
You'll be able to back it up. Okay. Excellent.
Daniel, if you want to remove the generator, drive shaft pass diagonal in from or the starter generator. Not sure if I understood
Yeah,
this
so
question.
there's a drive shaft that runs in front of the starter generator, but what you've seen so far doesn't really explain the full packaging in there, because there's also some duct work that provides ventilation around the engine, and there's also duct work to get the airflow into the inlet of the engine, so there's a bit more to it than that. So yes, if you want to take the starter generator off, you'd have to pop that drive shaft off, but that's not a complicated thing to do.
Okay. And Fernie is asking, I think we're just going to get down to the last couple questions here. We still got a few left, so we want to try to get as many as we can. Fernie is asking, since the world is changing very quickly, have you looked at adapting or building in any modifications for the future, like hydrogen or maybe some kinds of electric generator instead of fuel combustion?
So we're working extensively with a biofuel company to ensure that the engine is qualified to run on 100% carbon neutral biofuel. That's our primary strategy, which you will find will be the primary strategy for commercial air transport as well over the next 20, 25 years or so. Batteries are not going to work. I don't believe that hydrogen will work effectively for any size aircraft by the time all of the realities are factored in. And so that is the only way to deliver carbon neutral, economically viable air transport at any level in the near future. As I said, we are looking at electrical propulsion that will sit in our back pocket until such a time as there is a useful way to exploit it. One of my justifications for doing that at the moment is simply an electrically driven turbo-generated helicopter has a lot of profound safety and operational cost benefits over conventional configurations. So when we've developed that out, if it's weight competitive, we may look at rolling that kind of an architecture out, but that will be as far as we go in the short term. I think until a better means of storing electricity or a more sort of volume sensitive way of storing hydrogen becomes available, then those aren't the solutions for light aircraft. They won't work.
Okay, try not to pick the one that is more, let's say, broad for everybody. Has one of the last ones. What about simulator training? We covered that, right? And type rating. Actually, a little more technical. We did cover the simulator as a question to get ready to be ready for the experience. But what about the training itself and type rating on a simulator?
So flight training for early customers will be done by us, and we'll be enabling as many flying instructors and examiners from around the world to get rated as quickly as is humanly possible, because it's in our interest for these machines to be exceptionally well supported by the best instructors and examiners around the world. So we'll make sure that's as easy as possible and as practical as possible for people. So yeah, again, there will be a shortage of available instructors and examiners to start with. You will probably have to come to us because we've got to build that network, and it will take a little bit of time, but we'll support it and we'll get there.
Excellent. And I think we'll finish it off with this last question here. We always like to end on time if we can. And it's from Terry. And he says, are you looking at building the interior of this aircraft as basically with comfort and design like you would have a luxury English sedan?
Absolutely. Absolutely. Yeah, if you look back through some of the previous videos, we've got in fact, Josh, are you still... Have a look at the seat if you haven't seen the seat before. So, this is a seat that was, so the structure within the seat was built by us. So there's our carbon bucket inside that. This is our design. We've worked with a partner organization to develop out the trim strategy and approach from this, and there's still a little bit of work in refining this. We can get some more form into the seat, and we can slim the whole seat down so it's closer to the original design intent. But this is designed as a fully crash-worthy seat. Obviously, this one's sat on a display stand, but we've got the aluminium rails and the energy absorption structure in the back of it. We've got the stitch lines, the bum creases, we've got the embossed Hill logo in the headrest, perforated leather down the back and in the seat rest so that we can do the heating and ventilation. And yeah, we're pretty pleased with it as a production technology demonstrator. The production seats will be a bit tidier than that, but yes, this thing needs to feel like the best of premium British automotive manufacturing that you'd expect from any of the big names.
What a fantastic way to end this session with comfort. That was great, Jason. That was excellent. And we look forward to the continuation of the development of this dream coming true. Thank you very much, everyone, for attending today. We had more than 2,000 people connecting again, once more. We answered more than 70 questions from all over the world. Great to have you all. We welcome you again for the next session. We'll be announcing that soon. And have a great day, afternoon, evening, wherever you are. Thank you, and bye-bye.
Thanks, guys. Bye-bye.